Oops. And the only reason I'm doing that, I can actually fit curves better to this one. First, I'm going to go ahead and copy those data, insert in the charts, use this one with the dots, the scatter graph or XY graph. Just use, I'm going to use just this one. Let's move that to a new sheet. And to get a better, I'm going to make the maximum equal to. And these, I usually don't play around with the minimum value of the vertical axis unless I have a really good reason to do so, because doing so would exacerbate the slopes, and you would think that slope is really too steep, even though it's not. If you want to fit a curve, click on this series, right click, hit add trend line, okay? By default, it does a linear trend, but I'm going to do a polynomial with the order of 6, okay? And I want to display the equation on charts. Let's make this bigger, bolder, black backgrounds. In fact, I can make it even bigger. This is the equation for that 6-degree polynomial. It doesn't necessarily fit everything, but it does somewhat of a good job. Ideally, if you're doing this in practice, you do something called cubic splines, which makes sure that the fitted curve fits exactly the values that you know and interpolates the values in between. But for our purposes, this is good enough. So here I'm going to have coefficients or term. For some reason, my arrows don't work. So x to the power 0 until x to the power 6. 551.83 negative. Come on. What's going on? Let's see, control, okay. Negative 0.071, negative 0.5796, 280.56, negative 650.54, positive 469.112, and negative 1.0499. These are the coefficients. So if I actually give you a month, so let's do this here. Then we can calculate the fitted rate. I'm going to do something that I would hate if I was doing this for programming purposes, because this is not an efficient way of calculating the value of a polynomial. But that plus that times itself, let's make sure that all the G's are fixed. So this is the fitted rate. As you can see, it's not necessarily the same as the actual rate. But then again, those rates are rounded up to 2 digits. Maybe we should do that too. So I'm going to say round, whatever that is, to 2 digits. And I'm going to take this all the way to 360. All right. In fact, I'm going to divide these by 100 as well, so that I won't have to do it later. Come on. Yeah, close enough. Okay, those are my rates or fitted rates. Now, if I know the cash flows from a 10-year bond, I can actually calculate what the value should be. Mm, Let's call this one